Right. What do the directions mean? What am I supposed to do on this problem? We're going to substitute. So what does this letter out in front tell me? Why is it even there? Yeah, it's telling me which of these rules that they gave me at the beginning I need to use. Which rule do I want to use for the first one? I want to use f of x. So I'm using this rule here. What does the 3 part tell me then? Yep, that's what I'm going to put in the place of the x. So I have -6, and then we're going to substitute 3 in the place where the x is, plus 2. So I rewrote the function f, but instead of writing the letter x, I wrote 3s everywhere I saw x's. What is -6 times 3? -18 plus 2 is what? -16. So f of 3 is -16. So far, so good? Which rule am I using for number 2? Second one, it starts with a G here. I see the G rule right here, so this is what I'm recopying and substituting into. What are we putting in the place of the x this time? We're going to put -4 in the place of the x. So my rule has x squared, so I'm substituting in my x and then I'm squaring it. -2, and there's an x again, so I put -4 in again, plus 5. What do I get when I take -4 and I square it? Be careful. 16. Why is it not -16? Negative times a negative is a positive. If all you type into your calculator is -4 and then you hit the squared button, it will give you the wrong answer. You've got to put it inside parentheses just like we did when we substituted it if you want it to give you the right answer back. All right, then I come over here. I've got -2 times -4. That gives me what? -2 times -4. 8. I get a positive 8. And then I'm going to bring down that plus 5. When I add those 3 numbers together, 16, 8, and 5, I get what? 29. So G of -4 is equal to 29. For number 3, which rule do I go with? First rule, because it starts with an F. So that's -6, excuse me. And then we make our substitution, and then plus 2. What are we putting in the place of the x this time? N minus 2 is what I put inside those parentheses. Can I do anything to simplify this now? Multiply. We're going to distribute this -6. So I have -6 times n, that's -6n, plus 12. Negative times a negative gives me a positive. And then I'm going to bring that 2 down because I haven't done anything with it yet. Can I combine anything there? I can combine the 12 and the 2 together and get what? 14. So f of n minus 2 is equal to -6n plus 14. So far, so good? Awesome. We are going to jump into your books now. Yes. Page 143 in your books. Our next module is all about quadratic functions. Quadratic functions. If I graph a quadratic function, what does it look like? What does the graph of a quadratic function look like? 143. Starts with the letter P, a parabola. If we graph a quadratic function, it forms a parabola. General form of a quadratic function. They've broken it down, but general form is ax squared plus bx plus c. And we have names for each of these pieces. The first term right here, the ax squared, that's our quadratic term. Anytime we have something that's squared, it is quadratic. So I have my quadratic term at the front. The middle piece here, the bx, that's my linear term. And c on the end, that is our constant term. And that constant term is really helpful when we're graphing, because that constant term is my y-intercept. So I'm always going to be able to tell where the y-intercept is on the graph when it's been written in general form. Parabolas are shaped like a U, and so they have line symmetry. Do you guys remember back in the first module when we talked about line and point symmetry? This is an example of a type of function that has line symmetry. The axis of symmetry is that line. You can see on the graph here, they've got it with this dashed line. There's our axis of symmetry. The equation for that axis of symmetry, and we're going to use this a lot. Negative b divided by 2a. X equals negative b divided by 2a. So I'm going to put a negative sign out in front of my fraction. I'm going to take whatever number is right here in front of my linear term. That goes in my numerator. And then 2 times whatever this number is for my denominator. And then I simplify it, and that'll give me the line that runs right through my parabola. That axis of symmetry pulls double duty. It not only shows me where the line is that cuts through my parabola, but the x coordinate of the vertex is that negative b over 2a. So our vertex right here, that's either going to be my lowest point or my highest point. Negative b over 2a is going to be the x part of that ordered pair. To find the y part of the ordered pair, once I know what this number is, I can take it and I can plug it in for x in each of these spots, just like we did on the bell work, and I can see what we get back. That'll give me the y part. So far, so good? All right. There's another thing that we look at a for. Other than to be in my denominator for my axis of symmetry, a tells me whether the parabola opens up, like this one, so opens up like a cup, or whether it opens down like a frown. If the parabola opens up, that means our a value is a positive number. Where is the vertex on this parabola, the one that opens up? Is it at the top or the bottom of the parabola? Bottom. So the vertex down here at the bottom is a minimum. The y coordinate is the minimum value. If A is negative, which way does my parabola open? Down. Opens down like a frown. So if it's negative, down like a frown. If it's positive, it looks like a smile and it opens up. You remember doing that before?
Yeah, did we do it in 8th, 9th grade as well? I mean, yeah, 9th grade?
Yeah, should have been last year. Towards the end of the year, you guys probably talked about this a little bit. Yes, here the vertex is a maximum because it's up at the top. So vertex is a maximum. The y coordinate is our maximum value.
Now, isn't there like where you, not the maximum point vertex, but like it's in between the maximum and the minimum, but it's not the maximum. There was something else called that.
I think you were thinking about your zeros.
Not the zeros, like other points on the vertex.
Not on the vertex. Vertex is just that one point.
Okay.
Where it hits the x-axis, those are your solutions, your roots, your zeros, your x-intercepts. That's where we have all those synonyms come back to haunt us. Yes. All right. So far, so good? All right, I want to practice with this. Turn the page for me, 144. So they have given me this equation right here. F of x equals x squared plus 2x minus 3. Remember, my general form is f of x equals ax squared plus bx plus c. I want to try to identify what are the numbers for a, b, and c. So where would I go to find the number that's in the spot where a is? Where should I look? In front of the x squared. What number is in front of x squared? 1. It's invisible, but that is a 1x squared. So my a value is 1. What is our b value? 2.
Oh, yeah, we did.
What is our c value?
3. Negative 3.
Negative 3. C value is my y-intercept. So can we write the y-intercept as an ordered pair? What would that look like?
0, negative 3.
0, negative 3 for my y-intercept. To find the axis of symmetry, they gave me the formula. Are you all done? You want to keep working on it? Okay. Are you finished, Julie? Okay. You're welcome. They've written down the formula for us. X equals negative, and then B divided by 2 times A. So when I go to substitute this in on my own when I'm doing my homework, I put a negative sign and then I have a fraction bar. What value do I put up here?
Negative 2, the 2.
The 2. We put our B value up here. Divided by 2 times my A value. What was my A value?
1.
1. And then we're going to simplify that. Can I multiply the pieces together that are on the bottom?
Yeah.
Yeah, what do I get when I do that?
2.
2. So I have x equals negative 2 in my numerator, 2 in my denominator. Does that simplify at all? Negative 1. This is x equals negative 1. They didn't keep writing the x equals part, but they should have. X equals negative 1. That is the equation of the axis of symmetry. That is the line that is going to cut my parabola exactly in half. But it also tells me something else. What is the x-coordinate of the vertex? -1. The x-coordinate of the vertex is the exact same thing I find when I do the axis of symmetry. Was the a value a positive number or a negative number? Positive. It is a number bigger than 0. Positive number. So does my parabola open up? Or does it open down like a frown? Up. When it's positive, it opens up. So my parabola would look like this. Would the vertex be a maximum or a minimum then? Minimum. Our vertex would be down here. Yes, ma'am.
So what has to be positive for it to open up?
The only thing that has to be positive for it to open up is the a value. If a is positive, it opens up every time. If a is a negative number, it opens down like a frown every time. So far, so good? All right, so we're going to take this information that we've got right here, and we're going to use a table to help us come up with points to graph this parabola. I know the x part of the vertex is -1. I'm going to put that right in the middle of the table. So if you look down, I believe this is step 2. Right in the middle of the table, we put that -1. This is the x part of the vertex. We got that from our axis of symmetry. The other numbers in the table, these two here and these two right here, we just picked things that are on either side of -1 on the number line. I want a couple things that are to the left of it and a couple things that are to the right of it. Give me a couple numbers that are to the left of -1 on the number line.
-2, -3.
-2, -3, -4, -5. That's exactly how they came up with those numbers. They said, well, here's -1 on my number line, and I know that one. I know that's the x part of my vertex. So then we picked 2 whole numbers that came before it. And we want to pick a couple things on the other side of it too, because it's symmetric. +1, 2, 3, 4, don't forget 0. So 0, 1, 2, 3, 4. If we're counting by ones on either side, we want to keep that consistent on both sides, because there's a really cool pattern that's going to happen that'll make our work easier. First thing I'm going to do is I'm going to take this one that I have circled in yellow. We're going to substitute that in for the x in the equation. Everybody should have a yellow calculator in front of them. I want you to grab that yellow calculator and we're going to practice typing this in. Can you guys find the parentheses key on your calculator? All right, so we start with a parenthesis. What are we putting in for x first? -1. So in the place of this x, inside the parentheses, I'm going to do -1. And then what are we doing to that?
Then we close the square.
Close the parentheses and then square it. What comes after the -1 squared? +2. And then there's another x, so we're going to make another substitution. Parentheses, -1, close your parentheses. And then what? -3. Hit enter and tell me what you get.
-3 or -3.
-3. No, he asked, do I do a -3 or a -3 right here? Not what the answer was. Sorry, I didn't mean to confuse anybody. What did you get for your answer when you hit enter?
-4.
-4. So the vertex is this right here, -1, -4. It's right in the middle of my table, just like it's right in the middle of my parabola. So far, so good? All right, I'm gonna give you guys about a minute and a half, 2 minutes. I want you to follow that exact same pattern, but substituting in these different values for x. I want you to find the y parts of those ordered pairs. I'm gonna give you guys right about 2 minutes to do that. Right. When you put -3 in the place of x, what did you get for your output? Mm-hmm. 0. So -3, 0. Yes, sir.
Oh, that's it.
Got it. All right. So -3, 0. That's right here on the graph. We have another special name for that because it has a 0 right here. What do we call that? That's an x-intercept. All right, I got my volunteer for the next one. What about when we put -2 in?
-3.
-3 was the output. That's right here on the graph. We already got our vertex. We did this one together. What about when you put 0 in?
-3.
-3. Yeah. So, interesting thing, this one right here. What special name do we have for that guy? Y-intercept. And then you said the last one you got what kind of an output for that one? 0. Your book printed that wrong, didn't I? What did we put in for x here? You were supposed to put 1 in the place of x. Your book put a -3 right there, but that should be a 1 right here. And we got 0 as our output. That is over here on the graph. Do we have a special name for that point also? That one is also an x-intercept. So this graph has 2 x-intercepts, 1 y-intercept. We have a vertex. Did you guys notice any kind of interesting pattern happen when we were doing the table? Yeah, so we started in the middle of our table. We started with the vertex, and because we counted by 1s on either side of the vertex, notice on either side of our vertex, if I move out 1, they have the same y value. If I move out 2, they have the same y value. It's because it is symmetric about that axis of symmetry. These points get reflected over that line. If I were to fold them, they'd land on top of each other. Does that make sense? All right. Last thing I want to talk about is down here in step 3, we're going to analyze this graph. It keeps going to the left forever. It keeps going to the right forever. It extends to positive and negative infinity. So what is my domain? All real numbers. In interval notation, we write that as negative infinity to positive infinity, but that absolutely does mean all real numbers. For the range, we don't write our range like this. This is called set builder notation. We have not talked about it, and we're not going to. But I do still want to talk about the range. Does this parabola have a lowest point or a highest point? Lowest. We always start off our domain or our range by talking about the lowest or the smallest value. What is the lowest it ever goes? One more time. Still can't hear you. No, I want one single number. I want to know the lowest this parabola ever goes. -4. So I start off with my minimum. And then we have a comma. And then I want the maximum. Do we have a maximum on this graph? Does it have a place where it stops going higher? No, we have arrows up at the top. So how do I explain that it doesn't have a maximum? Infinity, yes. And we use a parenthesis after an infinity. Here's my maximum. This one has no max. Right. I want to compare two different functions now. In example number 2, they gave us a picture for one, and they gave us a verbal description for the other one. And we're going to try to figure out which one has the highest maximum. Are you okay? Okay. Still on page 144. We're about halfway down the page, a little bit past the halfway point. They gave me a picture for f of x. That's this guy over here. Is the vertex of this graph a maximum or a minimum? Maximum. Up at the top here, here's my maximum. It's my vertex. What's the ordered pair for this vertex? What's the ordered pair for that vertex? Let me see. 1, 2, I got 3, 5. Which piece of that is the actual maximum? 5. It's always the y part of my ordered pair. All right, I want to contrast that with the function g of x, which they did not give me a picture of, but they did describe it to me in words. And we're going to see if we can sketch a graph of this so that we can compare those. It tells me that we have a y-intercept of -1. What else does it tell me about this graph? Vertex at 1, 2. I'm going to go and plot that point. 1, 2 is going to be right here. Here's my vertex. So what is my axis of symmetry? The line that will cut my graph exactly in half. X equals 1, yes. Whatever this number is, the x part of my vertex, that's where I get the number for my axis of symmetry. x equals 1 is right here. It's this blue dashed line that I just graphed. They gave us the y-intercept too, didn't they? Where's the y-intercept? At -1. So 0, -1 is on the graph. So I'm going to go plot that point. 0, -1, right here. There's my y-intercept. Remember, the axis of symmetry cuts my parabola in half. So if I were to take this and reflect it over, there's going to be a matching point on the other side. Where is that matching point going to be on the other side of that line? If I were to fold the paper right here on this line, that point has a match on the other side. Going to be right here, right? What's that ordered pair going to be? 2, -1. So 2, -1 is also on the graph. If I have 3 points on the graph, can I sketch in a little U shape? Yes, let's sketch in our U shape here. What is the maximum for this graph? 2. The maximum, the vertex is 1, 2, but the maximum is the y part of that ordered pair. So the maximum is 2. Which graph has the higher or the bigger maximum? Top one. What was the maximum up here? 5. What was the maximum here? 2. 5 is bigger than 2. So F has the greater maximum. Because 5 is bigger than 2. All right. I want to look at one final problem with you guys. This is an application problem, a story problem. Example number 3 is on the next page for us. We're going to try to use what we know, what we just learned about parabolas to try to actually help this company out. A ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend pass. So they sold 680 passes, and they sold each of the passes for $120 per. This year, they're going to increase the price of that ski pass. Every time they raise the price by $5, they're going to sell 20 fewer passes. So if they raise the price up to $125, not as many people are going to want to buy it. If they raise the price up to $130, even less people are going to want to buy it. Every time they raise the price, more and more people are like, nah, too much. How much should they charge in order to maximize the profit? If we want to maximize the profit, maximize sounds an awful lot like what other word? Maximum. What part of the parabola would I want to look at if I'm trying to find the maximum? Yeah, look at the vertex. So we need some way of finding that vertex. Let's define our variables first. They're going to let X represent the number of price increases they decide to go with. P of X, this is their other variable, represents the total amount of money generated. By the way, P of X is exactly the same thing as Y. Function notation is interchangeable with Y. P of X is equal to the price of each pass times the total number of passes sold. They're going to be increasing the price of these passes, right? Every time they raise the price, they're going to raise it by how much? By $5. So 120 plus 5x would tell me the total price or the total amount of money they're going to charge for these passes times the total number of passes sold. How many passes did they sell last year? 680 passes last year. As they raise the price, will more people or less people want the passes? Less people. So that's that minus 20x. So 680 minus 20x. If I want to find the total amount of money that they've made, we take all the tickets or all the passes sold times the price of each pass. So that's what we're doing right here. So I'm going to multiply this and this together to get our equation. Since I've got two sets of parentheses, I have to use something called double distribution. To double distribute, I take this 120, this first number right here, that's going to get distributed to both of these. I need you to grab your yellow calculators again. We're going to do 120 times 680. What is 120 times 680? You said 600. What do you get if you take 120 and you multiply it to negative 20x? Yes, negative 2400, so minus 2400x. That's single distribution. I said we needed to do double distribution because I still have a 5x here in this first set of parentheses. That needs to get distributed to both of the other numbers. What is 5x times 680? 5x times 680. You said 7,400? 3,400? All right, thank you. 3,400x. What's 5x times negative 20x? What is 5x times negative 20x? Negative 100x squared, because I have x times another x, so I get x squared. How do I know which piece should go in front? How do I know which piece should be my quadratic term? What does the quadratic term always have with it? Go back 2 pages if you need to look. Page 143, we had them labeled. The quadratic term, how do I know which one is my quadratic term? Because that has to go at the front. A, what's next to the A? X squared. Which piece has an x squared with it? That negative 100. So negative 100x squared, this is my quadratic term. That means negative 100 is my A. What's the y-intercept? Which piece, A, B, or C, is my y-intercept? C, the one that doesn't have any variables at all. Which piece doesn't have any variables here? Yep, 81,600. This is C, my y-intercept, so that goes at the end. That leaves me these two middle pieces. We haven't done anything with these two numbers yet. What do I do with those? Negative 2,400, 3,400. What do I do with those? Combine them. Why am I allowed to combine them? They both have an X with it. What do I get when I combine those two together? What'd you say you got, Jaden? 1,000. That is my B term. Can we find the axis of symmetry from this?
Yeah.
Yes. How do I find the axis of symmetry now? To find the axis of symmetry, x equals negative, what does this fraction look like? What goes on top? B goes on top. What goes on the bottom? 2a. Negative b divided by 2a. So what am I putting in the place of b? No. That is not our b term. 1,000, because we had to combine these two together. They were like terms. I had to combine those to get my b value. So I have 1,000 in my numerator. What are we putting in the place of the a? Negative 100. All right, so we put 1,000 in the place of the b. In the place of the a, we put negative 100. What is 2 times negative 100? Negative 200. Turn it off. So negative 1,000, negative 200. Can I simplify that at all? Yeah. What is negative 1,000 divided by negative 200? 5. What did we just find? We found the x part of what? X part of the axis of symmetry. So x equals 5 is my axis of symmetry. Which means it's also part of what? If it goes with my axis of symmetry, it's also part of what?
The domain.
Not the domain. Well, it's in my domain, but that's not what I'm looking for here. Vertex.
Yeah, that would be my next.
That's going to be the x part of my vertex. So they're going to make the most money with how many price increases? What did we just find for x? 5. 5 price increases. So they should charge, they were charging $120. They're going to add $5 5 times. How much should they charge to make the most money? How much? 120 times, or plus 5 times 5.
145.
145, because 5 times 5 is 25. Yes. So they should charge $145 for the holiday weekend pass. We don't write set builder notation, so we're going to write our own notation in here. So what is the smallest number of weekend passes we could sell? Or the smallest number of price increases that we could have? Do they have to increase the price? No, they do not have to increase the price. So 0 is the smallest because we can't have negative. They're not going to go down. Up to a maximum of what? What is the most number of price increases we could have before nobody wants to buy these anymore? 5 is how many we're going to do to get to up to our maximum. Let's see if we can figure this out. I'm going to go back and look at this. Back here. 680 minus 20x. If I set that equal to 0, this will give me the biggest thing that x could be. The other one that we had was 120 plus 5x. If I solve both of these for x, remember x is how many price increases we're going to have. 120 equals negative 5x. What would I do to this to get x by itself?
Divided by negative 5.
What do I get if I divide this by negative 5?
Negative 24.
Negative
Whoa.
24?
Hold on.
Negative 24.
That's what I said?
Yep. I was
Oh,
just double
okay.
checking. You were the only person that had answered. Can we have a negative number of price increases?
No.
No, the smallest number of price increases I can have is 0. Can't be negative. What about this? This will give me the most. How do I solve that?
Divide both sides by negative. No, subtract. Wait, divide both sides by.
Mhm. I have to get the x on the other side first. How do I get the x to the other side?
Oh, subtract both sides by. Subtract both sides by negative 20.
If I subtract by a negative, that's the same as adding.
Oh, I be forgetting. Subtract the sign.
All right, so 680 equals 20x. How do I get x alone now?
Divide both sides by 20.
Divide both sides by 20. So what's the biggest x could go?
34.
34. So we can have anywhere between 0 and 34 price increases. More than 34 and nobody comes to this ski resort. Number of passes sold. Can we sell a negative number of passes?
No.
So what's the smallest for the number of passes that we can sell? What's the smallest number of passes that could be sold?
0.
0. Can't go into the negatives, so 0 is the smallest. How do I find the biggest here? I need my maximum, don't I? I know how many price increases will get me to my maximum, but I don't know what the maximum actually is. Let's take that number that we found, the 5, and let's substitute it into the equation that we had. Grab your yellow calculators. This is the last thing I'm going to ask you to calculate for me. Negative 100, and then inside parentheses 5. Close your parentheses and square it. Plus 1,000, and then inside your parentheses put a 5, and then close your parentheses. Plus 81,600. What do you get?
84,100.
84,100 is the maximum.
You put a 0 instead of a 0.
Oh, thank you. You said 84,100?
Yeah.
Okay, thank you for correcting me. That's the maximum amount of money, so that would be the largest Y value, 84,100. All right. That is where we are stopping for today. I do want to show you one thing real quick because they finally got McGraw-Hill talking to Canvas. So you guys don't have to go through Clever anymore. On our Canvas page, to get to the homework, all you have to do now is click the link for the homework. If you click the link for the homework, it will open up the McGraw-Hill stuff right here in Canvas. You don't have to go anywhere else for that anymore. Click the homework in there. Homework's due on Friday. We're going to keep graphing tomorrow. We're going to do something outside of your book tomorrow, though. I'm going to have a worksheet. We're going to do graphing on paper tomorrow. All right?
When are the tests going?
Should be back to you guys tomorrow. That's my goal.
All right.